Hello, let me check the sound and everything. I hope it's working. Yeah, okay. I think it works. Yeah, so let's start then. I will start the music. I will probably reduce the volume in my ears. Yeah. I probably did it too much. Okay. I hear the music. I think everything is working. All right. Let's continue. Let me double check. Is it working? Yeah. Okay. Yeah. Uh, yeah. Let's start. I had to skip stream last week because I was really busy with new work, and actually it's kind of miracle that I had time to prepare something for this weekend, but luckily I did. Yeah, so what I was doing long ago, actually I discovered some performance bottleneck. So this is our function which checks if target is in the line of sight, and this multi-peak with ray was a bottleneck, performance bottleneck. How I found this out, I was using profiler here. Unfortunately, they changed it completely, entirely, and honestly, I have no idea how to use it now, because before I was able quite easily to check which function is being called so many times and costs so much of CPU time, and that time I detected that it is multi-peak with ray, but now they change it and I honestly have no idea how to use it anymore. But since I remember what was the root cause, I think I did some progress. So let's do some performance tests. Right now we're running our old version of that function. Okay, and here is like FPS. You can see we have like steady 100 or something. And now see what's happening when all those cat demons will detect us and start to cast rays. Like, see how dramatically it drops. Okay, probably. Oh yeah. Okay. I didn't save. So let's try again. Okay, fresh start. So now you see it becomes like unplayable. It's like severe FPS drop, and it's terrible. So I came with several versions of improvement. So first one, this one, what is the idea? Instead of cleaning the hit array like that, get closest hit, what I do instead I use single peak with ray, but I use predicate function that cleans up unnecessary meshes, and it works fast. I actually did a couple more improvements first. Again, I spawn the array outside of the monster mesh, but what I also do, I deduct the offset from the full distance. And it doesn't seem like much of improvement, but I think it's nice to have. So our original array stretches from a monster position to target position, right? And because I spawn this array outside of the monster, technically I can cut it a little bit. I didn't do that before because I thought it's not a big deal, and in fact it's actually not a big deal, but well, nice to have. And yeah, then I just use this predicate function, and if it found something, that's great. There is only one problem though with this one. So if there are two targets on the line, let's say like two monsters on the line, and the target that passed here is behind, let's say, our monster, we will not see it. But you know, actually it's fine. If one monster is blocking in our, it's fine. So yeah, how it works. We doing a pick with ray, but we're skipping those that don't have mesh, those that are not enabled, those that are not visible, those that are not pickable. However, we don't really use this thing, I guess. Or we do, I don't remember. Yeah, also we're checking if this mesh is in the exceptions list, and if it's projectile, so when false, when we skipped the mesh, and we pick pretty much the first mesh which is not in that list and compare it to the target name. And yeah, as I said, we may pick some other monster first, which will not be our target, and this means that we don't see our target monster, instead of we're seeing something else. So this implementation doesn't allow monsters to see through other monsters along the line of sight to the target, and maybe it's fine, you know. So technically, yeah, monsters and targets can hide behind each other's back. I think it's okay. Well, that one works a little bit better with predicate version. Let's try, actually. Let me save. Okay, so let's see. You saw the previous time drop was like as slow as 30 FPS or something, right? So let's try this again. Well, it's slightly better, it slightly moves better, but yeah, eventually it gets messy anyway. It's a little bit better, I would say, when I did multiple runs, but still not good enough. And now we are coming to this beast. What we are doing here, well, it starts in the same way. We calculate our origin outside of the mesh, applying offset and calculating remaining distance, but right now we're going to use physics engine to check the line of sight. So how does it work? Havoc has a function raycast, and it can pick a physics body. And if we think of it, pretty much everything that can block our line of sight is a physical. Walls are physical, they have physical aggregate, and our monsters are also physical, they have some physics to it, so that's why you cannot pass through them. And ground also has physics, so this made me realize that technically we can offload this raycasting to the physics engine. And well, idea is pretty simple. It's just instead of casting ray like that, pick with ray, we are doing it from the inside of physics engine. We get our physics engine, we just do raycast. If we hit our physics body, we can extract it transform mode. Transform mode, it might be mesh, and in most cases it's mesh. So, and we can get this mesh name and compare the name to see if it's target or not. But here is important. This approach can get intersection only with very first mesh along the ray, and if it's not target, it means that this condition will not be fulfilled and it stops. We need to add possibility for those rays to look through certain meshes, through exceptions, for example, right? I mean, what it can be, like plane of glass. Monsters should be able to see through the plane of glass, right? So, and these physics rays cannot look through meshes. They stop when they hit something. So that's why we come up with that loop and with this max steps variable. So what it does? Okay, we're casting a ray, we hit something, but this something is not our target, it's an obstacle. So what we do, we check if our obstacle is in exceptions list. Exceptions are transparent meshes that we can see through, or maybe it's projectile. We also like a grid that we can see through projectiles because they are reasonably small, right? So if it's the case, if our first hit is a transparent obstacle, what we do, we just cast another ray in the same direction. So we get that hit point where we hit the first target, and we continue along the line. We shifting our origin for 0.5 units along the ray. We renew the remaining distance, right? Between like origin and current origin, we deduct this from the full distance. And yeah, we pretty much cast ray again. Our just current origin got updated. It was moved to the point which is 0.5 unit fewer than previous collision, and we can cast ray again. By manipulating this variable, we can do several attempts. So if we, let's say, have like 10 windows in the row that we won't allow monster to see through, we can change this to 10 and it will work. So what is the potential flaw of this approach is this thing. If our plane of glass is too thick, it's like very thick, then this shift might be not enough, but for realistic scenarios this should be working, I think. So I think 0.5 is quite reasonable, and I also think that 2 steps is okay. I don't really think that situation when we may have two obstacles in a row are that common. And even if we have something, let's say the ray is blocked first by bullet, then second by the glass, okay, we may skip this frame, but on the next frame we will come here again and detect it properly. I think it's fine, and let's see how much better it works. I mean, we still have kinda noticeable drop, but it stays way above 60 FPS. It remains playable. So why is that? Why is that happening? First of all, this physics engine for collision, it uses some bounding boxes, like physics body pretty much, which are much simpler than our mesh, so it's much faster to check intersections with both planes. And second, if I'm not mistaken, it uses special data structures, which are called oct-trees, to search meshes better. It's a kind of advanced spatial partitioning algorithm that allows us to traverse through possible targets fast. Technically, we could implement all of that on our own to use like with our rays, but why if physics already there and if all line of sight breakers also most likely have physics body, I just decided to utilize this thing. Those algorithms are already there and they are well optimized. And also one important thing, Havoc here uses a WebAssembly, so actual compiled code that is executed by CPU directly. So that also gives us boost. So we have pretty much two things inside. Optimized algorithm that uses simplified bounding boxes, and second, WebAssembly, which compiles code and executes it faster. And both those things in combination, they give us that boost. And another advantage, we still kind of have access to our JavaScript objects. For example, transform mode, it's a JavaScript class, JavaScript object, which exists only in JavaScript sandbox, which is executed by CPU. If we would try to do something like that on GPU level, this could be even faster, but GPU doesn't know about all our JavaScript objects. It doesn't know anything about our high-level objects that we defined here, and it will be a pain to decode result from GPU like back to CPU and match it with our object that we just hit. I mean, it's certainly possible, but communication between GPU and CPU here is much more complicated than communication between, let's say, JavaScript and WebAssembly, which is also done for us already behind the scenes. So yeah, I think it's a quite compromised solution, which gives enormous boost in performance, and maybe not as fast as GPU raycasting, but I think it's good enough. It gives us some flexibility, and I didn't really need to change anything except this function. There is one more thing that I had to change. and I will be back to it in a moment. There is one more thing that I should say here, is that that freezes that we have here, it's actually a CPU bottleneck. So if, let's say, we find better graphics card, it will not fix that issue, because those lags happening on CPU level, right? And well, fixing it on a CPU level may be not that bad idea, because offloading this to graphics card implies that we should have like more powerful graphic card to handle not only rendering but also this stuff, right? And here we offload it from graphics card and solve more or less efficiently on CPU level without worrying about communication between GPU and CPU. I mean, of course, if we solved all of that on GPU level and assuming that we have powerful enough GPU, it all would run even faster. Yeah, but as I already said, it's complicated to do so, at least to do it fast, and it may simply like not worth it, because not all optimization worth it. As you remember, a couple of streams ago, I tried to migrate to ES6 models instead, and in fact it became even worse. So that's why I stayed on this. It works just fine. It produces much smaller bundles, and in fact this like tree shaking in Babylon.js, it's absolutely non-native things. We are adding it only now, slowly transitioning to it, and you still have to import a lot of stuff for side effects. That thing is not really complete inside Babylon itself, so that's why probably sticking to its original form still works better for some reasons. And same here. It's interesting to try to offload it to GPU, but probably it doesn't worth it, at least now, because there are a lot of other stuff that we still have to optimize anyway on CPU level as well, regardless if we have powerful GPU or not. So yeah, back to it. Yeah, it all works right off the box by just replacing only this function, but there is a catch, and catch is with a player. You see, for most of our monsters and physics objects, we have this transform mode, and transform mode is a mesh pretty much, and we like assume that target name is always a mesh name. We're assuming that like object which has mesh and object name and mesh name are the same, which is a case for, let's say, for like most of monsters, because as you can see, when we create new instance, we cloning mesh and we assign name like same name to the mesh as well as the same name to the object itself. I believe we do it here. Okay, chain entity. Do we pass name here? No, we don't. Where do we assign it then? Yeah, okay, yeah. So that's pretty much the link. So when we call this, we pick mesh name and assign this name from mesh to the object itself as a shortcut. It works for all monsters and pretty much for all chain entities, except the player. And here is why. The thing is that when we add physics to the player, we're using this thing, a character controller, and it creates its own transform node, which is not referencing to our mesh, which we call actor hitbox. In fact, this character controller, physics body, it has transform node, but it's not this mesh. It creates its own, and we receive name mismatch. So mesh or transform node, which is referenced here in physical controller, it's not the same mesh that we create for player. And those names actually don't match. By default, it sets the name CC transform node, which means character controller transform node, and this leads to situation when this condition will not pass even if we hit the correct body. So the only reasonable solution here is to override the name in the player, override that physical transform node name, and yeah, this is what we do on this line. I added this line actually, as you can see. Yeah, so that's the only thing, but it works perfectly for everything else. And I believe if we check some other physical object, like let's say wall, we pass name, we assign name here, and so when we create mesh for that, this mesh builder, create box, we create the same name as here, and when we attach physics, like physics aggregate, we pass this mesh, so link preserves. When we hit physics body with array, we get reference to this mesh, and this mesh has the same name as entity, so it still works. So player was only an exception because we used Babylon.js native character controller, which creates its own transform node for that. That's why we had to address this. And yeah, this works, and I think it's good for now. Let's get back here. Let's clean this. But I was thinking, if we do something like that, can we probably optimize it in the same way for something else? Let's say for explosions, right? Or wherever we still use this multi-peak with ray, right? So let's see. I'm not sure. I mean, I'm actually sure that we will not finish with that today, but let's see. Hit not with ray. Okay, it's debugging function. That's okay. Somewhere here, yeah, explosion manager here. So we do the same thing, and I think we can kinda float it. But you know what? Before going here, I wanted to double check something. So let's go here. Okay, here are all our additional cat daemons that we added for testing purposes. For now, I will hide them. Okay, so, and I want to see if our monsters start chase each other. Well, practically I want to check if infighting is still working. So how I'm going to do that? We have this gate started, flying, ranged, yeah, combat unit. I will create just one more. Change the name. Actually, I should have like renamed Cat Demons here because it's getting messy. So yeah, we create one more and we do the same, but let's do, instead of this, we move it to the left a bit, well, relatively speaking, and I will try to make them in fight. So to see that they can really like track each other. So what do? I do okay. Okay, now they're chasing each other. Okay, it's terminated that one and got to sleep, and now, yeah, I guess they can do their things. Oh, okay. I mean, I think it's fine and it's quite logical. I didn't really expect that something may break there, because by the end of the day we're referencing the mesh exactly same way. So we get mesh, we check the target name, and it doesn't really matter where did we get that mesh. From classic ray peak or from this like Havoc raycast. Alright, I think we're good with this one. And I think really I can just revert those changes. So we're good here. And the explosions. Let's fix them. So what we're trying to do, so we get big mesh and we, if debug, yeah, color, then we extracting this destructible nodes, which are pre-populated. So here is our comparator. Yeah, we're trying to like compute damage and stuff. If it's not the case, then we don't do anything, but anyway, in debug mode we color it. I think it's a good way before starting actually enable debug mode. See how it goes. So okay, it tries to target two things, barrel, but it didn't hit because it faced the wall, and the glass, which it also didn't hit because it's like faced the wall again. So, but the main thing is when we're shooting this, we probably have enormous drop in performance. Well, I believe it's mostly because of this. Let's see if we're really experiencing it. Well, practically, unlike monsters, we only cast ray once per explosion, and we do it only in a single frame, while monsters were casting rays on every frame. So that's why having these standard CPU raycasts, JavaScript raycasts for explosions is not that dramatic. But we'll obviously see some drop, but it might be because, you know, particles entering and not only just raycasts. But we already learned that raycasts are extremely expensive, so let's just fix it. And so how does it work here? I think we're just getting closest hit. Yeah, we skip like exceptions. Yeah. So how we do it? Let's add general function for now, but probably later I will extract it into helpers and combine with the one that we have, because we really have a lot in common. And just for now, keep separately. So get hits, as simple as that. I probably put it above, right? Yeah, get hits. Actually, I also thinking that we should refactor Explosion Manager. I think it might be simplified, not for the sake of performance, but for the sake of simplicity, because with like damage stack it makes it sense, but I'm not sure if it's like very realistic thing to transport damage through several. I don't know, I need to think about it more, but it will require a lot of time to rethink that, and maybe I will like decide it to keep as it is. So yeah, instead of this, what we're doing, we have ray. For every destructible node, we create a ray. For every destructible node, we create a ray. So what we have? We have origin and get closest hits excludes itself, right? And sort by distance. Okay, it will be a bit hard. I mean, it's not hard, it's straightforward, it's just need to think longer. And yeah, we also have this like I think we still want to do race, but only for debugging mode, not for physics mode. And for physics, as you can see, can I keep origin for now? Just want to keep things simple. So let's say origin target what is the target? Target is indestructible node. Pretty much can be target name and exceptions. Like that. And to prove what we do where, we do something like this. And do exactly this. And target position, target, let me see, target position, target name, okay. Okay, target position, okay, so, and what we do next? Next we next we actually do our raycast and okay, still do like steps because we have exceptions. Okay, so we do like this. It's practically identical, I guess. What's the difference? Yeah, we don't have offset, which we probably should. But okay, so yeah, we're skipping projectile, we skip this. Okay, but that works just fine. Only our like exception yeah, so we don't do this actually. Current origin, origin position. Okay, it's like origin position. We don't do this. We just do this. Okay. and we return if we get hit, but we actually expect to return here the result, the mesh. So practically here will be null, here will be null, and here will be null, and we return only if true. We return this thing. So we should return hit mesh and hit point, hit point. Okay, so that's what we return here, and here we do like, let's say, result. Okay, hit, I can keep it as a hit, but so hit and call this get hits. So our origin is this, and target position, it's this thing, then name is this thing, name, what else? Exceptions, yeah, exceptions is this thing, get hit. Okay. All right, so if hit, we connect this, it will be hit mesh and hit point. We connect it like that, hit point. So this goes away. Let's see if we use, okay, we still use distance. Okay, but we don't need ray anymore. We only initialize it if we want to debug. And why it doesn't has the thing? Okay. Why did I declare that in such bizarre manner? It doesn't look like me at all. Is it though only for raycasting? Not really. This also needed for damage calculation. Direction, however, needed only to only for this raycast. Okay, that's a bit more complicated. Okay, let's take a look. Okay, it's okay. That's a minor thing. Where is it? Okay, it's here. Scene. Dun, dun, dun. Okay, remaining distance. Okay. All right. Okay, it's exploded. This one didn't explode. Very good. I mean, well, it sets things on fire. It triggers things. I mean, it works. And I'm not sure, but it feels like FPS dropped a little bit lower. It's barely happening. Let's try this. Okay. It can damage. What happens with rockets? Was it always like that? I mean, it works. The only thing that doesn't work is player doesn't receive any damage. I think it's probably gets like rejected again somewhere here. Let's see. So okay. Okay, it's actor hitbox. Why? Yeah, because this is how we. No, that's okay. That's correct. Actor hitbox and target name actor hitbox. It's actually that's passes. That's passes. Okay. Distance lower. That's why we have like computed damage of 11. Okay. Okay. I think that's our problem. Yeah, it's actor hitbox, but it's not the same. So it so it skips it. That's why. Okay. That's an easy fix. It's not what I ideally would like to see here, but I think this should fix it. Well, it certainly did. Well, it still does some sort of like FPS drop, but not that dramatic. And again, partially it might be explained because it's rendering rendering particles. And we can bring the ray casting back just for debug purposes. It doesn't color the stuff anymore, however. Why wall? Oh, it does. It's just so sometimes. Yeah, because it's probably not destructible node. I don't know why. It's a good question. So if I do it here, okay, it's exploded, but can I do it somehow without explosion? Yeah. So it tried to reach me, and it's like tried to reach these things, but those are safe because it was blocked by these barrels. Okay, that makes sense. Well, I mean, we proved that it works as a concept, but we need to do here a lot of cleanup because we obviously have duplicating code right now here, and in helpers it can be consolidated like 100%. Also, we probably can get rid of like these weird functions, and here I believe this create explosion function can be completely rewritten, and what we also can try to do is to actually cast the ray outside. outside of explosive. I mean, yeah, start casting ray. Outside of explosive mesh, but we still need to calculate damage as it's from the center. Yeah, I think this function requires a lot of rework, and maybe, you know, I was thinking maybe I will just remove this. I will I keep it as a as a backward compatibility thing, so we can inject destructible nodes, but I mean, I think we don't really need it. We can just get it directly from sector manager and like don't mess around with it. If we go in optimization after all, yeah, I want to rewrite this thing completely, but it will require a lot of boring testing, back and forth, like refactoring. I think I will just do it behind the scenes. At least I will try to do it before the next stream. If so, yeah, we will continue with that, and next time I present you cleaned up version. We consolidate this function and this function, and simplify this monstrosity. But yeah, will be a lot of testing. Yeah, good. It's a nice optimization, which actually doesn't touch a lot of code base, that's why it's relatively simple. Yeah, I guess we have something to keep us busy for next couple of streams without me required to like deeply inspect all the code base and think. And by the way, we have a lot of topics like that. We probably want to check if we can simplify weapons manager and how it's related to weapon class. It's a bit messy there. Then animation helpers, probably we can rethink it in some way. And sector manager, probably worth to be revisited. Yeah, there are a lot of ways to improvement. I really want to make it more maintainable before like expanding code base and start making like actual levels and stuff. But even now, our code is very, very capable and extendable. But as for me, right now it just it cannot scale at the pace that I want to scale. So that's why I want to simplify it even further, because when we start dropping in more imported entities and more levels, yeah, it can be a little bit hard. And yeah, performance is another thing. This is what we did here. It's more like ad hoc solution because we fixed that particular function, but other than that, we probably still need to rethink these collision things. Like, for example, here, try to move, try to climb. Those functions also seem like very evil for me in terms of computation. Because I would really love to have this engine being capable to do slaughter maps at some degree. Of course, I mean, in modern games, you don't see like slaughter maps in the classical Doom 2 sense, because 3D rendering is slow, and even like modern games, like let's say Doom 2016, maximum amount of monsters that can exist at a single moment is capped by just 12, I believe. And you simply cannot spawn more monsters where more than 12. I think mostly because of like rendering limitation, not like raycasting stuff. But yeah, since Quake first was released, amount of monsters on the screen simultaneously like dropped significantly, even though like Quake really used those bounding box collisions really well. Yeah, so it's simple if you like want to work with a real 3D, so you have to limit amount of entities that you can have on screen, but at the same time I have still very big potential, because when I was developing this sector manager, I was able to maintain hundreds of entities moving simultaneously. Yeah, they didn't do raycasting and they were just simple blocks, but still I think we can easily achieve like more or less stable gameplay, having like a couple of dozens entities. But again, by the end of the day, it will be restricted by complexity of rendering, which means by complexity of measures. It's not hard to do with cubes, but for humanoids, yeah, we may hit something. And we also have big limitation with the fact that we're all running into the browser. But I think this is exactly why all those optimizations and hacks, they are important. My PC is quite old already, like 5 years old, but potentially people may run it on even older laptops, and I want to have my thing somewhat performant. Yeah, when I release it, I believe computation power increase even fewer, and I will not need to worry that much about it. But yeah, I enjoy the progress. I enjoy simplicity that we bring slowly to the stuff, particularly even this thing, which we can just declare our monster in serializable files. We need to do the same for world builder, for walls and stuff. Yeah, to make our like gaming engine not a thing of its own, but something that people actually can use to build their own stuff someday in the future. Alright, too much talking. Thank you everyone who joined today, and I see you next week, same time I guess. I hope I will find time to clean up this mess, should not be a problem. So yeah, luckily we have some things to do for next weeks, which luckily will not require a lot of preparation from my side. That's why we can continue. Right, thank you everyone who joined today or who watched recording. Have a great upcoming week. Bye.